1 2 1 2 1 2 1 2 1 2. Woo!
Hello guys and welcome back to this one. So today we are going to be looking at the debugger tool illustration of this solution, and we're going to be seeing how the code goes through this code base, and we see what we've already understood, the concept we've already explained and understood now in practical flow through a system and delivering us the result that we want. So let's just get into it. So you can see here obviously our max heap. We've explained how a max heap works, and then we begin to go through the for loop. So the for loop says, okay, it takes out the first guy. So begin to look over here. Let me zoom in so that we get a clearer look. Then we could drop this as well. So we could then go ahead to step in. Now when we step in, I think it's ideal for us to see what we're doing. So this is our 0, right? So that's the first guy. The star code, we're looking for the distance. Distance is returned. We consider distance is 100. Then we say if max heap is less than k. This is k. The length of max heap is what? Is 0. So we could see here the max heap is still 0. There's nothing in it. So basically, we just push stuff into it, right? So we push stuff into it, so you can see max heap begin to increase. Now max heap has a maximum value of 3, because that's what we stipulated k to be. So no more than 3 values can get into it up until you hit this else statement. So let's just watch it go through. Come back here. We hit it, so it gets populated. Let's just go to it and you can see it get populated. So we have 125 inside the stuff, inside the function right now. We come back again. Boom. Because obviously we are calculating the distance, right? So we have a distance of what? Minus 125 and 10, 100. So with what we've had here, what we have here right now, okay, it's already a no-brainer. It's right there in front of you. I wanted to see if you understood how the max heap works, because now we could see that minus 100 is at the tip of this max heap, right? And you can see that the smaller values, or rather the bigger values in the sense of the minus, are on this other side. And that's because minus 100 is less than minus 20. But if you check it on the other end of the spectrum, 25 is less than 100. So yeah, we could immediately see how the max heap works by using the minus to keep these 100 guys up. So yeah, we continue, but this time around, this if statement will not be satisfied. Would not be basically satisfied, because now we are not going to jump into that. We're going to go to the else, and now we're going to compare the 100 with the guy coming in. So who is this guy coming in? Our fourth guy, or more like our third guy. So that's 002. That's 4. So we are going to now compare. We're going to bring it out from the heap, right? We're just going to pop this guy from the heap, right? Because if you look, okay, let's just imagine. Let's see what our max heap is. So no, this guy right here. So we see the farthest is 100. So we pop out 100, which is the edge of the guy, edge of the heap. Basically, we're not popping it, we're just we're just basically examining what that is. And then we say minus d. So we can see here now the reason why we do the minus d, because d over here is what? What's the value of d? The value of d here is 4, because that's the distance we got when we solve 0 to this thing. 020, right? We get 4. Now we are saying minus 4 should be greater than minus 100, greater than 100. Now why are we adding minus at this end? Because now we know we are working in the minus spectrum, right? We are working in the minus universe. So we have to convert it to a minus, so that we can then check if 4 is greater than if minus 4 is greater than this guy, which is minus 100, and in real terms it is. So what do? We switch out 4, right? So that's what we do. The heap the replace. Then we take out the guy that is coming in, the guy that's going out, and then bring in the guy that's coming in. So that's basically the process. You can see that 4 is updated, and 25 goes to the tip of the maxi. So we just continue in that manner. We hit this guy again, and boom, we hit 5. This should give us 75, right? So we got to 75 from the distance of this guy. So when we compare it to the tip of the 3, we get 25, right? So you can see here we get 25. So when we say it's minus 75 over here, so when we say minus 75, is it greater than So let me show that a bit longer there. So but basically what I'm trying to show us is obviously the same thing we've seen before, where minus 4, which compared what was coming out of here, which is 75. Minus 75 is greater than minus 25. So it basically returns a false statement. So there's no, we're not going to call this block of code because it's not needed to switch anything around. So yeah, having said that, we can then go ahead to see maxip. Let's continue with this guy. So we're done with the follow. Now see maxip or reverse. So everything that we have here now, we just turn it around because one fun, because what this guy does is that it turns everything around as a maxip by using the minus sign. So we turn everything around again. So now we turn everything around. I don't think maxip now becomes an object. So we just basically can't see situations from it right now. So after being reversed, we can then now say for I in stars, right? Equals to maxi in maxi to now print out the ID and then the stars minus, because one is still bearing that star. One is still bearing that minus. All of them are still bearing that minus. So for us to print them out without any friction, that's why we turn it around to get it in numerical order and then remove the minus by printing it with minus, because minus times minus is, yep, science students are in the house. So yeah, it's equals to 1, right? And basically that's it for this one. Basically we've seen everything, we've seen the code run through. Let me see if we could just allow it play through, right? So let's allow it play through, because here we reversed, so now we're seeing for loops. So let's see if we can. So you see, so it's printing out 125. Let's see if we can get, so you can see it's here 1, 4, and 25. It's printed out without the minus sign. So yeah, that's basically what we're looking for, right? So we are done, and we have seen all the solutions up until now. We've seen the code explanation, we've seen the graphical illustration, the debugger tool. Now we are done. So yeah, we've seen every of the illustrations from brute force to every graphical line here now, and we see the waste, and we see how this guy does not go to every file to check if it's allowed to go into the stack and be the list, but we have a system that basically automates that for us. And yeah, we have seen that. So the next bit now is going to be the complexity, and we are going to then expand on it and show the clarity there of how it compares to the brute force. So muchas gracias. See you on the next one. Bye.